Hello, everybody, and welcome to the next lecture on Introduction to Psychology. Um, going to be rushing this one a little bit, so let's see how much we can get through in this one session. All right, and as always, this material has been brought to you by has been published by Flat World. Um, and today's topic is Chapter 2, Research Methods of Science, the Science of Psychology. And the learning objectives for this section are going to be to explain the difference between basic research and applied research, describe peer review and explain its value, identify and describe the 6 sections of a research article. All right, so basic research, what is it? So basic research is about discovering new knowledge and understanding how things work. It's like exploring and asking questions just to find out more about the world. So an example would be scientists studying how plants grow under different light conditions, just to understand more about plant biology. And the goal would be to increase our knowledge, even if it doesn't have an immediate practical use. So that's different from applied research. Applied research is about using knowledge to solve specific problems or making things better. It's like taking what we know and figuring out how to use it in real life. So an example would be scientists are developing a new type of light that helps plants grow faster for farmers to use. And the goal of that would be to find a solution to practical problems or improve processes and products. And comparing these two, both types of research are important for advancing our understanding and improving our world. But basic research focuses on gaining new knowledge just for the sake of learning. And applied research focuses on using knowledge to solve specific problems and create practical applications. So basic research is like exploring and learning just because you're curious, while applied research is like using what you've learned to solve a problem or make something better. Hopefully that cleared that up. All right, so let's go ahead and talk about the video is age restriction. Oh yeah, okay. So I'm not going to go ahead and click on this video. It is a video with John Oliver on research. You can go ahead and click on that and watch it yourself. So I'm not going to play the video within this video, but we'll actually go over this in class. So let's talk about the parts of a um, uh, research paper. So the first part you'll see is something called the abstract, and this is like a summary of the whole paper. It tells you what the study was about, what the researchers did, what they found out, why it's important, all in a short paragraph. So think of it like the blurb on the back of a book that gives you an idea of what the book is about. Another analogy I like to use is think of it as a trailer to a movie. You get all the highlights of the movie, but you need to go see it for yourself if you're interested. The next part would be the introduction. It's at the beginning of the paper. It explains what the researchers are studying and why it's important. It might also mention other studies that have been done on the same topic and what questions are still unanswered. So it's like setting the scene before you tell a story. The method section, this describes exactly how the researchers conducted their study. So this thing includes details about who or what they studied, how they collected their data, and any tools or techniques they used. This part's important because it helps other scientists understand exactly what was done and try to do the same thing to see if they get similar results. Speaking of results, this section shows what the researchers found out from their study. So it includes data and observations. Often this is presented in tables, graphs, or charts, and this is the part that's showing the answers you got after doing some kind of science experiment. Then we follow with the discussion section, and that explains what the results mean. So researchers talk about whether their findings support their original ideas or hypotheses, how the results compare to other studies, and then what the implications of their findings are. So this is a part like discussing what you learned from an experiment and what it might mean for the future. And then at the very end, you have your references. So this will be a section that's dedicated to listing all the books, articles, and all the sources that the researcher used to write the paper. It's like a bibliography for a school project showing where you got all your information from. So Hopefully that clarifies what's in the research paper. Okay, didn't switch. Here we go. The next section. So let's go ahead and go to 2.2. Learning objectives for 2.2 are to describe the principles of the scientific method and explain its importance in conducting and interpreting research. Differentiate laws from theories and explain how research hypotheses are developed and tested. Discuss the procedures that researchers use to ensure that their research with humans and animals is ethical. I won't go too much into animal research in this lecture, but I will talk about it. All right, the scientific method. We touched on this in the previous lecture. Let's go ahead and start off with understanding what empirical means, or reviewing what empirical means. So empirical just means it's based on observations or experiences rather than just theories or ideas. So in science, empirical evidence, this is the data that scientists collect by doing the experiments or making those observations. It's like when you actually perform an experiment to see what happens instead of just guessing what might happen. So for example, if you wanted to know if plants grow faster with more sunlight, you would grow some plants with a lot of sunlight and some with little sunlight, and you measure their growth and look at the difference. The measurements that you take are going to be the empirical evidence because they're based on real observations. Following that's the objective, and the objective. This means it's not influenced by personal feelings. It's not influenced by interpretations or prejudices. Excuse me. It's about being fair and unbiased. So, in science, being objective means looking at the facts and evidence without letting personal opinions or emotions get in the way. So, for example, if you're measuring how fast plants grow, you would use a ruler to measure their height instead of just guessing. This way, your measurements are based on factual data rather than what you might want or what you expect to see. So scientists, what they'll do is they'll try to be objective so that they can ensure that their findings are reliable and not swayed by personal belief. So when you put this together in the scientific method, the scientific method being empirical and objectively, right? Those are crucial. So empirical, scientists, just for recapping, scientists gather data through experiments, observations, they get real tangible evidence. This is to help them understand how things work in the real world. Objective, meaning that scientists analyze the data they collect without letting their own opinions or biases affect the results. And this will ensure that their conclusions are based on facts and not influenced by their personal feelings. So by being both empirical and being objective, science can conduct fair and accurate experiments leading to trustworthy and reproducible results. Scientific law. So what is scientific law? Unlike civil and criminal law. So scientific law just describes something that always happens under certain conditions. So based on some kind of observation, some kind of experiment that's repeatable, scientists will gather these descriptions and put them into, or formulate them into a law. So a good example would be the law of gravity. This says that objects fall to the ground because of gravity, just simply stating it like that way. The goal would be to describe how things work in the natural world, often with some kind of mathematical formula. So the certainty of this law. So laws are generally accepted as true and universal. They don't explain why something happens, just that it does happen. When we talk about scientific theory, we want to know if it's a well-tested explanation for why things happen. It's based on a lot of evidence and helps us understand the underlying reasons why something happens, some natural phenomenon happens. An example would be, right, the theory of evolution, and that explains how species change over time through natural selection. The goal of that would be to provide an explanation for observations and laws and to make predictions about future events and to gather information about the certainty of that law. The theories would be supported by a lot of evidence but then they can be modified or refined as you find new evidence. So as new discovery occurs, you modify your theory. They explain the why and the how. And comparing laws and theories. So both laws and theories are based on scientific evidence, and they help us understand the world. The difference is between the two is that law describes what happens. It tells us about a consistent relationship observed in nature, like gravity, making everything fall. Where a theory, it explains what happens. It provides detailed understanding of the underlying mechanisms. The theory of evolution explains how and why species change. So when you look at scientific law, it tells us what happens every time under certain conditions, while a scientific theory explains why and how those things happen. All right, so let's go ahead and talk about this chart when we try to lay out the laws and theories as organizing principles and what makes a good theory. So let's first talk about organization and organization and what it means to be to have a good theory, or what it means to support a good theory. So a good theory, when we talk about the organization, it helps to organize a lot of information in a way that just makes sense. And an example would be, think of it like an organized binder for school notes. It helps you find and understand information really easy. And why would that be important? Well, it helps scientists understand how different facts and observations fit together. The next quadrant on this graph is parsimonious. What does that mean when it relates to a good theory? So a good theory is simple and doesn't have any unnecessary part. It explains things in the easiest way possible, which is what Einstein was famously known for saying. And an example would be imagining that you're explaining a math problem using the fewest steps possible. The simpler the explanation, the better. Why would that be important? So simplicity makes a theory easier to understand and makes it easier to test. The next factor there that would make a good theory in the lower right-hand quadrant would be falsifiable. What does that mean? So a good theory can be tested and proven wrong if it's not correct. And an example would be if you have a theory that all swans are white, it can be proven wrong if someone finds a black swan. Right? Why would this be important? So being able to test and potentially disprove a theory helps ensure that it's accurate and reliable. And then on the bottom left quadrant, provides ideas for future research. What does this mean? And what does it have to do with a good theory? So a good theory gives scientists new ideas for experiments and studies. And an example would be if a theory suggests that a certain plant grows better with more sunlight, it can lead to new experiments to test different amounts of sunlight on a plant growth. And why would that be important? It helps science keep moving forward by inspiring new questions and new investigations. So overall, a good theory is well organized, it's simple, it's testable, it inspires new research. And this is what makes a powerful tool for understanding the world and making new discoveries. Let's go ahead and move on to the research hypothesis. I'm sure you're familiar with this. So a research hypothesis is like an educated guess about what you think will happen in your experiment. It's a statement that predicts the relationship between two or more variables. So before you start your experiment, you come up with the hypothesis based on what you already know or what you have learned from other research. For example, again, if you're studying how sunlight affects plant growth, your hypothesis might be plants that get more sunlight will grow taller than plants that get less sunlight. This hypothesis predicts a specific outcome that you can test through your experiment. A variable. What is a variable? It's anything that can change or vary within the experiment. So there are two types of variables that we deal with. The first one's independent variable and the second one is dependent variable. The independent variable, this is the variable you change on purpose to see what effect it has. So in our plant experiment, the amount of sunlight is the independent variable. because you can control how much sunlight each plant gets. The dependent variable in that experiment is the measurement or the observation that you see within the changes as it responds to the independent variable. So in our plant experiment, the height of the plant is a dependent variable because it depends on the amount of sunlight they get. There are also things called control variables, and these control variables which are all of the factors that you keep the same in your experiment to make sure that any changes you see are really due to the independent variable and not something else. For example, you might keep the amount of water, type of soil, and the type of plant the same for all of your plants. Right? So you control for all of those other factors. When you put all this together, you conduct an experiment. You start with a research hypothesis, which is your educated guess about what will happen. Then you identify your variables. So again, when we talk about the independent variable, the thing you change, we talk about the dependent variable, the thing that you measure, and then the control variables are the things you keep the same. So by carefully changing the independent variable and measuring the dependent variable, you can test your hypothesis to see if it was correct and to control for any controlled variables. Does that make sense? All right. Make sure you ask me questions in class or on email. All right, the research hypothesis continued. We're going to talk about the operational definition as it pertains to the research hypothesis. So an operational definition is this clear, precise, detailed description of how you will measure a variable in your experiment. So it's like giving exact instructions so that anyone else who wants to repeat your experiment can do it the same way you did. So when you create an operational definition, you explain exactly what you mean by your variables and how you will measure them. So this ensures that everyone understands exactly what you're talking about, and they can measure it in the same way you did. An example would be, let's go back to our plant experiment with the hypothesis. Plants that get more sunlight will grow taller than plants that get less sunlight. Right? We said the independent variable is the amount of sunlight. Well, the operational definition would be something like, we will measure the amount of sunlight by placing some plants in full sunlight for 8 hours a day, some plants in partial sunlight for 4 hours a day, and some plants in the shade with no direct sunlight. And this is something that's very easy to understand and repeatable by other researchers who repeat this. Now the dependent variable, right, is the height of the plants, and so the operational definition for the dependent variable would be something like, we will measure the height of the plants in centimeters from the base of the stem to the tip of the tallest leaf using a ruler. By giving these operational definitions, I know that was very basic, but you make it really clear exactly how you will measure the amount of sunlight and the height of the plants. This helps ensure that your experiment is consistent and that others can understand and replicate it. And why is this important? Because operational definitions are what remove ambiguity, and they make your experiment more reliable. So if you just said you were measuring sunlight and plant height without specifying how, different people might measure these things differently, and it might lead to a different type of experiment, and you would get inconsistent results. So to summarize all of this, operational definition is a detailed description of how to measure the variable, and our example was specifying the exact hours of sunlight and the method of measuring the plant height. So why is this important? Recapping, just ensures consistency and reliability in the experiment. So hopefully that helps clarify what an operational definition is, or what is an operational definition. All right, so this particular slide, we got quite a few operational definitions and variables that we can discuss. I'm not going to go through all of these because they're on the list for you, but let's just mention a few. The first one being aggression, right? So an operational definition for aggression, how you would measure it: the number of presses of a button that administers shock to another student. Right? The number of seconds, oh, by the way, that first one is very similar to something Stanley Milgram did in an experiment. Another way to measure operational definitions, to provide an operational definition for the variables for aggression, is looking at the number of seconds taken to honk the horn at the car ahead after a stoplight turns green. I think we're going to talk about that one in class. Let's see what else we can mention here in the slide, but that is definitely one good for a class. Decision-making skills. Depression is a good one. The number of negative words used in a creative story. So we may actually do this as an example in a class. The number of appointments made with a psychotherapist. Right? So those are operational definitions that you would use to measure or control the variables. Well, yeah, manipulative control. All right, so conducting ethical research. Let's go ahead and jump into a big concept of conducting ethical research, and the first concept is deception in research. And deception in research means that the researchers might not tell the participants everything about the study, or they might mislead them about some part of it. This can result sometimes this might be needed in some cases to get accurate results. I mentioned this with the Stanley Milgram experiment and how it was considered unethical, but I also mentioned that it would be very difficult for him to have gotten his results without using the protocols, which he did. I may assign as a optional reading or watching. There's a video on it for the class. So it brought up ethical questions in his studies. So the ethical dilemma is a situation where you have to make a tough choice between two things that both seem important, but are in conflict with one another. So in the case of deception in research, the dilemma is between getting accurate results. So sometimes if participants know all the details about the study, they might change their behavior and the results won't be accurate. For example, if you're studying how people react to stress, but you tell them that you're going to create a stressful situation, they might act differently because they know what's coming. Being honest and respectful. It's important to be honest with participants and respect their right to know what they're getting into. So deceiving people can make them feel tricked or upset, and it might harm their trust in research overall. A good example would be, imagine you're doing a study to see how people respond to unexpected challenges. You might tell participants that they're going to do a simple task, but then you suddenly make the task much harder without warning. This way you can see their genuine reaction to the challenge. However, you didn't tell them the whole truth about the study. And so you see they start developing a mistrust. Almost seems like a prank, but a scientific prank. So solving this dilemma, researchers, what they do is try to solve it by following some agreed upon important guidelines. And the main one is to minimize deception. So not completely get rid of it, but minimize it. So use deception only when absolutely necessary and when there is no other way to get accurate results. Get informed consent. So before the study, participants should be told that there might be some elements they aren't fully informed about, and they should agree to participate knowing this. And a debriefing. So after the study, researchers should explain the true purpose of the study and why deception was used. They also can answer any questions that participants may have had to make sure they're okay with their participation in that experiment. These are things that didn't happen during the Stanley Milgram experiments. The last thing would be review by ethics committee. So most research studies involving deception, they need to be reviewed and approved by an ethics committee. And this ensures that the benefits of the research outweigh any potential harm to the subjects, the participants. So summarizing all of this, deception in research, not telling participants everything about the study, that's what it is. The ethical dilemma is balancing accurate results with honesty and respect for participants. The solution to the dilemma would be minimizing deception, getting informed consent, debriefing after the experiment, and ensuring that it gets reviewed by an ethics committee before you implement the experiment. So if you follow these guidelines, researchers aim to conduct ethical research while still being able to study important questions. Again, I hope all of this has helped you understand a little bit more about deception and conducting ethical research. So let's go into another one of these graphs when we talk about 4 areas that lead to ethical concerns, and you see them from I'll say clockwise: prevent harm to research, guarantee participants free choice, minimize deception, and protect the privacy of the research. Starting off at the top left is prevent harm to research participants. And what does this mean? Well, scientists have to make sure that the people who take part in their studies are safe and that they're not hurt in any way. So a good example would be a study that involves testing a new medicine. Researchers, they make sure that it won't cause any serious side effects to the participants. Why would that be important? Because keeping participants safe is the most important responsibility of research. Moving clockwise, guarantee participants free choice in taking part. So what does this mean? People must decide for themselves if they want to be in a study. They shouldn't be forced or pressured to participate. So as your instructor, I cannot say, in order to pass this class, you all have to participate in 3 studies done at the college, and you have to go sign up, and I have to have proof that you took part in these studies. I can't do that, but that actually is done, just so you know. So but if a school is doing something like a study on their students' eating habits, students could choose if they want to be part of it or not. Something you are already doing. Why it's important? Everyone has a right to make their own decisions about being in a study. The next one would be protect the privacy of research participants. So this means that researchers have to keep personal information about participants private, and they can't share this without your permission. A good example would be if you participate in a study about your favorite books. Seems harmless. The researchers shouldn't tell others which books you like without asking you first. And it's important because people need to trust that their private information will be kept safe. It's also important for the future of research, because if people stop trusting the researchers, they'll go into research as participants, hesitating to participate fully. The last quadrant that we're going to talk about that deals with ethical concerns is minimize deception in research procedures. And this means that researchers should avoid lying or tricking participants. If they have to use deception, they have to explain it afterwards and make sure it didn't harm anyone. Now, in the Stanley Milgram experiments, no one was actually hurt, but the idea that someone was hurt was left in people's minds, and that may have traumatized some of the participants. So a good example, besides the Stanley Milgram experiments, which I think probably led to most of this reform, is that if a study involves telling participants a fake story to see how they react, the researchers need to explain the real purpose of the study after it's over. And it's important because being honest and transparent is crucial for maintaining trust between researchers and participants, and we want to maintain that so that research can continue uninhibited in the future. So to summarize all this, ethical concerns in research are about making participants safe, making sure they have the freedom to choose, keeping their information private, and not to mislead them. These are all concerns that research is concerned with when we're looking at being fair and respectful to participants. All right, so ensuring that the research is ethical. This is just summarizing. This is the Institutional Review Board. So every campus, every university that does research with human subjects, they have an Institutional Review Board. And this is not just for campuses, this is also for teaching hospitals, any place where research is done on human subjects. So the Institutional Review Board will look at the procedures, policies, make sure that you have a protocol for making sure that your research is ethical. Some little trivia that you might want to know: the committees consisted of at least 5 members whose goal is to determine the cost-benefit ratio of a proposed research. So they'll determine whether your research is warranted, and anything that you're doing, does it require human subjects? Is it worth the trouble? Or is there any other way you can do this without the human subjects? All right, so now let's talk about ensuring that research is ethical, talking about informed consent and debriefing. We mentioned those earlier. Informed consent is like getting permission from someone to do something after you've explained all the important details to them. So in research, it just means that before someone agrees to be part of a study, the researchers have to explain everything they need to know so that they can decide if they want to participate, if the participants want to participate. So key points of informed consent would be a good explanation. And by the way, this is not just for research, this is also for healthcare. So use that as a parallel to understanding this about research. So when we talk about explanation, researchers tell participants what the study is about, what they will have to do, and how long it will take. You do the same thing in healthcare. You have to explain to the patient what any procedure is about, what it's going to do, how long it's going to take, whether let's say they're in surgery or in therapy or so forth. Risk and benefits. So in research, participants, they're told about any possible risks like discomfort, stress, and any potential benefits like learning something new. Obviously, in medicine, we do the same thing with risk and benefits. We offer therapy for some benefit, but we also lay out the risks and the probability of those risks to the patient. Voluntary participation. Again, this is true for both patients and for research subjects. Participants, they need to know that they can choose to take part or not. So they have to be told this right up front. They can stop at any time without negative consequences. This is based on something called the white coat theory, or the white coat phenomenon, the lab coat phenomenon. It all goes back to Stanley Milgram's experiments on obedience. I can't wait to actually talk to you about that study. It'll lay out a lot of the reasons why we do all this today. Same thing with patients. Patients have to know right off the bat that they can choose to or not to participate in the therapy. They can choose not to take the medication or the medicine or participate in the therapy that the doctor provides. So they have to know that up front. Questions. So the participants should have the chance to ask any questions they have before they agree to join the study. Same thing with the patients. They have to have an opportunity to ask questions to the doctor before they actually agree to any kind of therapy. So an example in research would be if a researcher wants to study how different types of music affect studying, they would explain to the participants what the study involves. You're going to be listening to music while studying, and then you're going to take a test, and any risks. So you may be feeling a little stressed during a test. Right? Tests are stressful. What are the benefits? Well, learning how music might help their personal studying as far as participants are concerned, and future participants in the general public, how they might respond to music when studying. They also need to know that they can stop participating at any time if they feel uncomfortable. Now let's talk about debriefing. So debriefing is like having a conversation after the study is done to explain what really happened, especially if any deception was used. It's used to help participants understand the full purpose of the study, and you can also address any questions or concerns that they may have at this time. Key points to debriefing: you will always have an explanation. So researchers explain what the purpose of the study was and why certain things were done the way they were done, especially if any information was withheld or if there was any deception. Good time to explain it. Reassurance. So researchers at this point, they can make sure the participants feel okay about the participation and address any concerns they have. Within the Stanley Milgram experiments, he just let them go off back out into the world, not knowing what they participated in. Results for this can sometimes lead researchers to like what they found and want to share it with others. Yeah, sometimes not. Questions. So like before, questions. Participants can ask questions that they have about the study. I'm going back and forth in my head between patients and participants of research. Sometimes they're both, right? Sometimes it could be a research study in psychology where they're just trying to get information from the general public and it's a random population, a random sample. And sometimes it could be where they're very specific about the type of subject and it actually is a patient who's undergoing some therapy and some medication, so you can be both. The participant can be an actual patient that with an actual condition. So back to our study though, it would be our music study. So the example of ours would be that after the music and studying experiment, the researchers could explain to the participants that the true purpose of the study was to see different types of music affecting studying differently, right? If there was any deception, in other words, if participants were told something that wasn't the whole truth to keep the results accurate, the results if they have them right there in hand, how the results will be used. Then they can answer questions that the participants may have that they didn't actually address. And that's it. Informed consent, getting permission before the study by explaining everything that's important to the participants, and debriefing, explaining what really happened after the study. Again, especially if you used any deception in your experiment. So both informed consent and debriefing is what researchers, wow, I think I'm developing the list. What researchers use to ensure they have ethical studies and that patients and participants or participants are treated with respect and honesty. All right, just gonna briefly talk about this. I won't get into too much detail in research with animals. You can ask me questions in class. I've supported and worked in animal research, lab animal research. So basic principles have been developed to guide scientists in making ethical decisions about research with animals. Most scientists believe that there are sufficient benefits from animal research to justify such practice as long as the humane treatment of the animals is guaranteed. That is a great discussion for an ethics class. Not psychology. Takeaways from this section. Psychologists use the scientific method to generate, accumulate, and report scientific knowledge. Organizing principles include laws, theories, and research hypotheses, give structure and uniformity to scientific methods. Concerns for conducting ethical research are paramount. Researchers assure that participants are given free choice to participate and that their privacy is protected. Informed consent and debriefing help provide humane treatment of participants. A cost-benefit analysis is used to determine what research should and should not be allowed to proceed. And the learning objectives for this section: differentiate the goals of descriptive, correlational, and experimental research designs and explain the advantages and disadvantages of each. Summarize the use of correlational research and describe why correlational research cannot be used to infer causality. And review the procedures of experimental research and explain how it can be used to draw causal inferences. 38 minutes. We're doing good on time. Okay. Let's go ahead and jump into each one of these. Descriptive, correlational, and experimental. So the first one is descriptive research design. Descriptive research is about observing, describing things as they are. It doesn't try to find cause and effect relationships. So a good example would be a study that records how many hours students spend on homework each week, and the purpose would be to gather information, detailed information, to provide this clear picture of what's actually happening. What it doesn't do is explain why some things happen. It just looks at what is happening. Correlational research, this looks at the relationship between things to see if they are connected. So an example would be a study that examines whether students who spend more hours on homework get better grades. and the purpose would be to find out if there is a connection or some relationship between the two things. What it doesn't do is show that one thing causes the other. It just shows that they're related. Experimental research. This is research that tests whether one thing, a variable, causes another thing to happen by manipulating variables and observing the effects. An example would be a study that divides students into two groups where one group gets extra homework help and the other doesn't, then compares their grades to see if the help made a difference. The purpose of this is to determine the cause and effect relationship by controlling and changing variables. So what it does, it can show that one thing causes another thing to happen. So comparing all three, comparing and contrasting, all three designs are used to learn more about the world, but they have different methods and different goals. The contrast of each three, the descriptive research, it observes, describes things as they are without looking for any relationship or any causes. Correlational research, it examines relationships between two things but doesn't determine cause or effect. And then experimental research, this tests cause and effect relationships. It does it by manipulating variables and observing the outcomes. So, this is descriptive research, tells us what's happening. Correlational research tells us if two things are related, and experimental research tells us if one thing causes another. That's a good summary. Hope that clarifies things. Let's talk about case studies, surveys, and naturalistic observations in populations. So first, a case study. Right? This is an in-depth study of a person, a group, or some situation. I think we have case studies in the textbook. An example would be a scientist that studies a student who has a unique talent for math to understand how they learn and how they solve problems. And the purpose would be to gather detailed information and insights about a very specific subject. What it does, it provides a deep understanding of one particular case, but it doesn't really apply to everyone else. Right? A survey, this involves asking a large number of people questions to gather information about their thoughts, their feelings, or behaviors. So an example would be a school that conducts a survey to find out how many students like different school lunch options. And the purpose would be to collect data from many people to see a common trend or opinions. And what this does, it gives a broad overview of what a large group of people think or does. The naturalistic observation, this involves watching people or animals in their natural environment without interfering. I mentioned that I'm reading a textbook. I'm reading a book called The Wisdom of Wolves, and I'll refer to that book now and then. So a researcher will watch, for example, how students interact during recess to understand how they make friends and how they play. And the purpose of that would be to observe, record behavior in a real world setting. What it does is provide a realistic picture of how people, or in the case of The Wisdom of Wolves, how animals behave naturally without any influence from the researcher. So if we compare all three of these, they're all used to gather information and describe what's happening, but they use different methods. If we contrast these, a case study focuses deeply on one specific subject. A survey collects information from a large number of people through questions, and a naturalistic observation observes behavior in a natural setting without interference. So case studies give detailed insights, surveys collect data, and naturalistic observations watches behavior in real world settings. Now I mentioned population and random samples. So what is a random sample? Random sample is a group of the people or things chosen from a larger group, and it's chosen in a way that it's chosen from the larger group in a way that every person or thing has an equal chance of being selected. So it's not targeted. It's random, and that random should be very similar to the larger population. So it's like picking names out of a hat where everyone has an equal chance of being picked. Purely random. And this is important because it aims to describe what's happening in a certain population. So when you use a random sample, that just helps ensure that the sample is representative of the entire population. This means that the results of the study are more likely to be accurate and not biased in any way. An example would be, imagine that you want to find out the average number of hours that 8th graders at your school spend on homework each week. So if you only ask your friends, your results might be biased because your friends might have similar homework habits, similar to yours. Instead, if you just ask a bunch of random people, you're more likely to get a realistic answer for what the class does. So we can create steps to creating a random sample, and the first one would be to make a list. Write down all the names of, in this case, let's say the 8th graders in the class. You assign them all numbers, so you give each student just a particular number. And then you just find a method of randomly selecting them. Like you put numbers in a hat and draw them out of a hat, or you can have a computer program that generates numbers randomly, as long as you're completely isolated from that process where the choosing is, you wouldn't know who's being chosen. So after that, you can survey the sample that you have. You ask students whose numbers were picked about their homework habits, if we're doing the 8th grade homework habit experiment. And why this is important? It's important because you want to get fair representation of everyone in the classroom. So imagine that information for the study habits of 8th graders in a class would lead to how much funding they would get for certain technology, right? That would help them with that study. So if students were already studying, if students were already interested in studying and they're giving it their best, maybe that qualifies them for something. You can't tell them that at the beginning, but again, you want to make sure that it's fair, because maybe another class down the hall is actually studying, and if a class knew that was the result, they could easily, lie on the survey. Or if you only pick the best people in the classroom to make it look like the entire class is actually studying, then again, that would be unfair to the other class. So you want to make sure you get fair representation. This reduces bias. So maybe for some reason you want a particular class to get the benefits because you know people in that class, you know the teacher, or something about it, versus another class, you may not dislike them, you just don't know them. So you try to do anything you can to remove personal bias. This also will give you a better accuracy of what's actually happening in the population of the class, and that's actually more important because it'll let you know maybe if the teaching methods are effective or not. So randomly, a group chosen in a way that makes it possible for anyone to have been included, sort of like, well, no, I was going to say jury duty, but I think jury duty, you have to have a license or something like that. This is important because it just, again, a recap, ensures fair representation that everyone can be selected. Anything about jury duty? I just said jury duty. You want a random sample of your peers to serve on juries. That way, you know you're getting a fair trial. If you somehow fixed it so that the trial was of a certain group or certain people of a certain opinion, that definitely would not be a fair trial. So you want it to be random as much as possible. Okay, let's talk about correlation, positive and negative correlation. So positive correlation, this just means that one thing increases, another thing also increases. Or if one thing decreases, the other thing decreases, meaning they follow each other. One goes up, the other one goes up. One goes down, the other one goes down. As far as like the dependent and independent variables. An example would be the more time you spend studying, the higher grades you tend to have. So if you study less, your grades might drop, right? Unless you're a genius. So both things move in the same direction. They both go up or they both go down. Negative correlation means that as one thing increases, the other one decreases, or vice versa. As one thing decreases, the other one increases. An example would be the more time you spend playing video games, the less time you might have for doing homework. And if you play video games less, you might have more time to do homework. Right? So the things move in opposite directions. Right? One goes up while the other goes down. And then you can have something where there's no correlation. That just means that there's no relationship between the two things. Changes in one thing don't predict the changes in the other. An example would be the number of hours you sleep and the color of your shoes. They have no effect on each other. Whether you sleep more or less, that doesn't change the color of your shoes. It may change the color you choose in the morning for your shoes. I don't know. But I don't think it would be scientific and repeatable. So what's important about this? There's no connection. One thing doesn't really affect the other. That's it. Let's go to the next one. Let's talk about scatter plots in correlational research. Right, seeking relationships among variables, and scatter plotting is one way. And it's a type of graph, and it shows a relationship between two different things, two different variables. It helps you see if there is a pattern or a connection between the variables. How it works is you have an x and y axis, and the scatter plot has two axes. The horizontal axis represents one variable, and the vertical axis represents the other variable. And then you place dots at each coordinate where you have one event, right? One observation. So these are plotted on the scatter plot, and you can see the examples of the scatter plot there. It looks like just a bunch of polka dots, right? But they tend to have like a swarm, if you could look at them like insects, where they're all going in one direction. And that's kind of what you're looking for. So if you're plotting, let's say, height and weight, each dot shows height and weight of one person. And you just do a bunch of different measurements on a bunch of different people, and you can see what the trend looks like in that population. So you may have a relationship between the number of, let's say, hours students study and their test scores. It could be a lot of different things. Right? So you have a positive correlation there. That could be the more hours, the higher test scores. Negative correlation could be like the one with the video game. You play more video games, you study less, and your scores go down, I guess. No correlation. What was the example? You sleep longer, and it relates to a particular type of color shoe, and it doesn't matter. There is no actual correlation. So no correlation would look like that, like a big old cloud. What else? That's it. 26. So let's look at some examples, right? Correlational research, seeking relationship among variables. This one I'm just going to read through the slide and go through it slowly just so we can go through. This is something that's talked about in the news quite often, right? Seeking relationship amongst variables. So correlational research does not allow causal conclusions. A positive correlation between a number of violent TV shows, for example, the violent TV shows children watch, and the scores on a measure of aggressiveness play can mean what? That viewing violent TV leads to aggressive play, or that aggressive play leads to wanting to watch more violent TV, or looking at the third pair, viewing violent TV and aggressive play, levels of aggressiveness in the home. So not that they're related to each other, violent TV and aggressive play, but there's just some third variable or something that you're not controlling for, which is aggression in the home. Right. So there is correlation, but we don't know what's causing it, in other words. Independent variable, this is a variable we mentioned. It's a variable that the researcher changes, the variable that the researcher manipulates on purpose to see how it affects something else. Think of it as the cause in an experiment. The dependent variable is what the researcher measures or observes to see if it changes because of the independent variable. So you can think of this as the effect of the experiment. So let's say you're doing an experiment to see if the amount of sunlight affects how tall plants grow. The independent variable is the amount of sunlight. It's what you change in the experiment. You might have different groups of plants that get different amounts of sunlight each day, 2 hours, 4 hours, 6 hours, 8 hours, probably, yeah, 10, 12 hours. The height could be the dependent variable, so the height of the plant. This is what you measure to see if anything's actually changing because of the amount of sunlight they're getting. So you measure how tall each plant grows after a certain period. And so you would write some steps in the experiment. So one, you would choose the independent variable, decide what you want to change. For our example would be the amount of sunlight. Create different groups. So set up different groups that get different amounts of the independent variable. That would get different amounts of sunlight. So one group can get 2 hours, another group can get 4 hours, and another group can get 6 hours. Then you measure the dependent variable after a set period of time. So measure the dependent variable in each group the same way. And so our example, you measure the height of the plants. You measure them the same way, whether it's the 2, the 4, the 6 hours. And that is our understanding of the causes of behavior and how we get it through experimentation. So by understanding these variables, it helps you design experiments that can show cause and effect relationships. Again, changing one thing like an independent variable and measuring what happens through the dependent variable, you can see if there's a direct link between them. And hopefully that makes sense. All right, let's go ahead and talk about random assignment to conditions. This is, again, experimental research, understanding the causes of behavior, random assignments to condition. So random assignment to condition in experimental research is a way that researchers use to make sure that each participant in an experiment has an equal chance of being placed in any of the different groups or any of the different conditions of the study. So it's like flipping a coin to decide which group someone will join. So if it's completely fair and unbiased, so if you're going to be joining, let's say, a team, you don't get to pick your own players and pick your best players. It's just random. You flip a coin. Whoever ends up on what team ends up on what team. It's not the way we play sports, but yeah. And this is important in psychology or in the scientific method, because the main goal of random assignment is to ensure that the groups are as similar as possible to the start of the experiment. So you might remember when you were kids and you were picking teams to play, you know, football in the street or baseball, whatever you're going to play, and it's time to pick teams, and you have 2 captains, and what would they do? They'd start picking the best of whatever role they needed in their team, and the last person picked was usually the one with the least amount of skills. That would not be a random assignment to conditions. So sometimes you'd get a team with better players, right? And well, that's the goal of the professional sports. So I would say that's probably the goal of collegiate sports as well, and high school sports. So imagine you're doing some experiment to see if listening to music while studying improves test scores. Then you have 2 groups. You have group A listens to music while studying, and then group B, they study in silence. But you have a random assignment, meaning you randomly decide who goes into group A and who goes into group B. So you have an even chance of not having any kind of bias. Right? So how do you do it? Give everyone a number and pick names at random. Put names in a hat, pick them at random. Listing, like I said before, listing participants, putting other names down, selecting randomly from some type of process. That way everyone gets an equal chance to be selected for either group. This just reduces bias, improves fair comparisons, and increases the validity of your tests. By the way, all this can actually be utilized too in hiring practices, which I knew was very unscientific. All right, we're almost done with this presentation, so let me just go ahead and read the takeaways from this last section. So we talked about descriptive correlational experimental research designs and that they're used to collect and analyze data. We specifically talked about descriptive designs include case studies, surveys, and naturalistic observations. The goal of these designs is to get a picture of the current thoughts, feelings, or behaviors of a given group of people. Correlational research designs measure two or more relevant variables and assesses a relationship between or among them. The variables may be presented on a scatter plot to visually show the relationships. Experimental research involves the manipulation of an independent variable and the measurement of a dependent variable. Random assignment to conditions is normally used to create initial equivalence between the groups, allowing researchers to draw causal conclusions. Okay, we're almost out of here. The last section, learning objectives, we're going to talk about the 4 steps to the SIFT test, and we're going to apply SIFT test to an example. And I'll talk to you in one slide what the SIFT test actually is. Right? So, it says, have you read or heard about some research findings in the news or on social media? If you haven't, I would say stop the recording right now and go back and watch the John Oliver recording way back in the first couple of slides, and then get back to this slide. Second, are you curious to know whether what you've read is true? So to evaluate a claim, apply the SIFT test. And what is a SIFT test? We're going to go through this in a little detail. Right? So the SIFT test is just a way to decide if information you find online is reliable and trustworthy. And it stands for stop, investigate, find, and trace. So this is how you use it. First, go back to the John Oliver recording and pause at each one of those cases that he brings up, those articles. Not the articles, the news representations of the articles. So stop. What does it mean before you believe or share something you find online? Take a moment to think about it. Right? The second thing is how to use it. Don't rush to share or act the information. Take a pause and consider if it might be true or false. When you get to investigate, what does that mean? Or investigate the source, what does that mean? Check who created the information and if they're trustworthy. How do you use that? Look up the author and the website if they're experts. Do they have a good reputation? For example, information from a well-known news site is usually more reliable than some random blog. But as you saw there from those news organizations, that also may not be the best choice. Part 3 is find better coverage, the F. What does this mean? It just means that see if other reliable sources are saying the same thing. How can you use this? Look for articles or reports from trustworthy sources that talk about that same topic. If you have a lot of reliable sources and they agree, the information leans toward being true. And the last one is trace, right? Trace claims, quotes, and media back to the original context. So this means that you follow information back to where it originally came from to see it in full context. And how do you use this? You see if a quote or a piece of data, you find out where it first appeared and in what context it appeared. So sometimes things can be taken out of context or misquoted. See a lot of that in the news today. And a good example would be if you see a post on social media and it's claiming that a famous person said something shocking. First you would stop, take a moment to think before you react or share that post. You investigate, look up the source of the post, see if it's reliable, see where it came from. You want to find better coverage, check if there are other reputable news sites reporting on that same story, and then you want to trace, find the original interview or statement where the person supposedly said the shocking thing and if it was quoted correctly. So you can use the SIFT test to sift through this data and information to make sure that you have something accurate and trustworthy. I think that's the last slide. That's it. Takeaway for this last section. The SIFT test allows you to carefully evaluate claims. SIFT means stop to consider the source, investigate the reputation of the source, find more information on the topic, and trace the information back to the original research. And with that, I want to thank you for your time with this lecture, and I will see you in the next session.